Hello everyone, it's Arthur here from gdotv. Today I'm here to tell you a little bit more about Apache AGE, a graph extension for PostgreSQL. Now, at gdotv we have a habit of working with a whole bunch of different graph databases, and Apache AGE is one that we found lately to become quite popular, and so we thought, let's talk a little bit about it. We've written a blog post series with links in the description that will walk you through pretty much everything that we're talking about in this video. So first of all, we're going to try and explain a little bit more what Apache AGE is exactly and how it works. We're going to draw some comparisons with popular alternatives and other relevant developments in the graph on relational space. Then we'll quickly walk through some options of how you can run Apache AGE and where you can potentially deploy it. Next, we'll just go over a really simple tutorial that shows you how to load a sample dataset on your graph database. And just finally, we'll do a lightweight exploration of what we've just loaded so you can see how it looks like and how it behaves. So throughout this video, I'm going to use a mix of some URLs, some gdotv screen shares, just to kind of show you how it all looks like. So first of all, right now, I'm on the Apache AGE official website. And that's going to tell us just a little bit more about what it is. Really simply put, Apache AGE is a community Postgres extension that allows you to run lightweight graph workloads directly on PostgreSQL. It supports the Cypher query language, more specifically the OpenCypher version of it, with a pretty substantial set of features supported in that language. And the ability to actually run SQL queries with a mix of graph workloads and regular SQL workloads. Now, the way it works, really simply put, is that it allows you to create graph data directly on PostgreSQL. Now, why would you want to do that? Imagine that you have a dataset that is not well suited to, deep traversals, say anywhere between 3 and 6 hops. And that you're trying to get something set up that matches potentially your existing infrastructure. With PostgreSQL being one of the most popular databases in the world, there's a good chance that you'll either have it already in production or that you'll have a very good understanding of how to get to production. And so this community extension will just allow you to very simply create graphs on your PostgreSQL instance, load data into them, and then start querying them with Cypher. And it's going to do all that storing the graph data separate from your pre-existing relational data on your PostgreSQL instance. Now, one of the big reasons why Apache AGE is attractive is because it runs specifically on Postgres. And Postgres is, frankly, the most mature relational database, at least open source, that's available out there. And so if you're deploying a graph extension on Postgres, you're also going to gain access to a whole host of benefits that come inherently from Postgres itself, and that's going to be anything from backup and recovery procedures to deployment, observability, etc., etc. And so that just means where with a standard graph database, there might be some less mature offerings out there on that side of things. With Apache AGE, you both have access to this wide array of features to make it easier to manage your database, but it also just runs on something that you already have, which is Postgres. Now, how exactly does Apache AGE work? The really simple version is that when you're creating nodes and edges on Apache AGE, they're going to be created under a specific graph that you're going to declare beforehand. And that graph is going to have a schema declared within your Postgres instance that's going to be used to store tables that will store the actual nodes and edges data. The way it does that is really simple. It simply stores one row per node and per edge on separate tables for each label for your database. And it will then store the properties as JSON-B values within those rows, just to allow you to have the flexibility of not necessarily having, exactly matching property names and types across all of your nodes across like a similar label or similar for an edge. It just means basically it's all there in Postgres without a need for anything other than to simply install the extension. Installing the extension itself is a pretty simple process, but we'll cover that in a minute. One thing that's interesting to talk about, first of all, is how exactly does it compare to other graph databases and other offerings out there? So, I mean, first of all, the really important thing to say is that if you're looking for large-scale graph workloads, and you'll think millions or billions or above, Apache AGE is just not the right choice for you. This is not a optimized to the maximum solution when it comes to graph workloads. I think you should rather just look at it as a very convenient option that you can use if you're looking for smaller graph workloads that you want to deploy very rapidly and potentially on your existing infrastructure. Now, that means, if you're looking for a similar language, but you're looking, Cypher it is, but you're looking for large-scale workloads or more complex graph workloads in general, you're going to want to look at Neo4j or FalcoDB, memgraph, etc., etc. This is where you're going to find your best fit. The other interesting comparison that we can make with Apache AGE is with the upcoming SQL PGQ support on PostgreSQL itself. SQL PGQ is a property graph querying set that's part of the SQL 2023 standard that actually allows you to declare property graphs on top of existing relational tables and to then query it via graph queries. Now, when it comes to SQL PGQ, first of all, it's not available as of time of recording on Postgres just yet. It will be released most likely around the end of 2026 as part of Postgres 19. And another key difference, well, there are two key differences here as well. First of all, SQL PGQ uses standard SQL language for graph queries with some new functionalities within the language that allow you to do that. It's still a similar pattern matching based language, but it is not Cypher. The other thing is that SQL PGQ works on top of your pre-existing relational data. And so what that means is you already have tables on your Postgres instance, and you're trying to deploy a graph workload on top of those tables. Where this is really important is that if you just want to do a graph workload on top of existing data that is strictly constrained to the tables that you have in your database, then all you have to do with SQL PGQ is declare a property graph on top of this, and then you'll be able to query as a graph. SQL PGQ, at least on Postgres as of now and the way it's being discussed by Postgres developers, has some similar limitations around performance. And so comparisons around other graph databases like Neo4j or memgraph or FalcoDB or others out there like Neptune still apply. But it has an added advantage over Apache AGE, which is that it layers on top of your pre-existing data. So with Apache AGE, you're still going to need to load your graph data into Apache AGE. With SQL PGQ, you can just put straight on top of what you already have. So that gives you a general overview, quite detailed, of what Apache AGE is and generally how it compares to some of the other offerings within the graph database space. We're not going to compare to every single graph database that exists out there. That would take quite a while. There are a lot of them. But generally speaking, any comments around the performance at scale for graph workloads would apply equally whether you were looking at Neo4j or Janus Graph, for instance, or perhaps even AltipaGraph. It's still the exact same trade-off of convenience and operability versus performance. So now that we've laid all this out, we're going to briefly discuss how exactly can you run Apache AGE. Now, it is a Postgres extension, but it's not a Postgres official extension. Broadly speaking, what that means is that in theory, it should be very easy to install it on your Postgres instance and run it. But in practice, there's some caveats. The main caveat that comes with this being an extension, a community extension, more specifically, is that depending on where you're deploying Postgres in production, for instance, you're not necessarily going to have access to the extension itself. That's going to depend on your PostgreSQL provider. Now, of course, if you're just managing your own PostgreSQL instance within your own environment, then you have full control over how it runs and what you can do with it, and you're completely unbound as to how exactly you're going to run it. However, if you are using one of the cloud offerings as far as deploying PostgreSQL goes, is going to be a bit more of a mixed bag. So in this little post, links in description, we've put together a sort of general view, which is valid as of today, of what the landscape is for deploying Apache AGE in production. Now, one of the, I want to say, pioneers in terms of supporting this specific project is Microsoft Azure, who have added official support for Apache AGE as of 2025. First in their Azure Database for PostgreSQL product, but also coming up soon under Azure Horizon DB, which is, again, at time of recording, in early access preview mode, meaning you might not actually be able to use it just yet unless you've already been pre-approved to have it. And so for these two, deploying Apache AGE is very simple and fully documented. It just takes a couple of clicks to enable the extension, and then you're good to go. Enterprise DB similarly has support for Apache AGE as a maintained extension, meaning that you can very easily install it and use it. For other PostgreSQL offerings across the different cloud providers, so we're going to just cover AWS and Google there to keep it simple, that's just not there yet. There's, as of now, no sign of official support for Apache AGE either on Amazon RDS or Amazon Aurora. And so if you're trying to deploy Apache AGE in AWS, your only option really is to run your own PostgreSQL instance that's self-managed and not part of either of these managed PostgreSQL services. For Google Cloud, it's a similar situation. However, for Google Cloud, there's, I believe, very good reason for it, which is that they offer the powerful Spanner Graph and BigQuery Graph as part of their Spanner multimodal and BigQuery multimodal offerings. And whilst they don't use the exact same language and they have some slight differences in terms of behaviors, in terms of actual, it's not just very close to Apache AGE, but in fact far superior to it, because it allows both the ability to deploy on top of existing relational data, but also to perform more ad hoc creation of vertices and edges, nodes and relationships, via, for instance, Spanner Graph's own schemaless data for graph feature. We're not going to cover the details of this, it's very, very long, but in this article we are covering a little bit more about this, so I recommend you read it. If you're with Google Cloud, these are two very, very good options to be looking at for your graph workloads. Now finally, and this is not an exhaustive list, although it is quite long, Supabase, for instance, has talked about Apache AGE before and simply said, look, if you want to do this specific type of graph workload, use PG routing instead. So we don't really see any signs that they would suddenly offer this as a maintained extension. And Snowflake, to our knowledge, well, first of all, does not support it as of now, but we have witnessed some minor signs online of activity around Apache AGE specifically, which could suggest that in the future it might become available. The street data is conjecture. There's absolutely no tangible proof other than a few commits and pull requests from Snowflake folks on the Apache AGE project, as well as a few discussions online. Now, as far as trying out Apache AGE itself, in this video, we're going to keep it very simple. We're going to just run it with Docker. So, super convenient to run. Apache AGE publishes its own Docker image. Long story short, it just ships Postgres with the extension pre-installed and configured. All you have to do is run the container and you're good to go. And so you can see here it's as simple as just Docker run, which is a very similar experience actually to just running Postgres itself. Once you've got Apache AGE up and running, you've got a few options as to how you're going to work with it. Now, you can just simply use the Postgres command line tool to start running queries and commands, etc., to be able to use it. Or you can use other official or unofficial Postgres clients. It will work because ultimately the way that Apache AGE wraps the the Cypher language is via a SQL function called Cypher. And so that means you will still be writing SQL. You will just have to write Cypher within SQL. The other option, this is what we're going to do today. If you're specifically looking at doing graph within Postgres, then you can use gdotv. gdotv is the tool that we make here. It's a graph database IDE compatible with a really wide array of graph databases and languages. Apache AGE is one of those graph database technologies that we support officially, and we've shipped a bunch of features that just make working with Apache AGE in general much easier. So this is what I'm going to show you next. And to show you all this, we're going to take a really simple, we're going to load a sample data set that just represents airports and their routes, and then we're going to start visualizing it. So with all that, we're just going to quickly jump over to Docker first of all. This is my Apache AGE Docker instance running. I'm going to take a few shortcuts in the video. I've mounted some CSV files that contain the actual data that we're going to be playing with, and we're going to go through those in just a minute. We'll connect gdotv to Apache AGE, and then we'll just start by loading the data, which is literally just going to take half a minute, and just exploring it. So first of all, if you don't have gdotv just yet, simply head over to https://gdotv.com, gdotv. Download the software and install it. It's available on Windows, Mac OS, Linux, pretty much the whole shtick. So you're going to have support there. And then you're good to go. Once it's installed, you can just run it and start connecting to your database, which is what I'm going to do now. So to connect to Apache AGE, really simple. And as I've mentioned before, we support a lot of graph databases, but we're going to pick AGE. We're going to enter our connection string, which is just the standard JDBC connection string. So in our case, it's localhost 5432, which is the standard Postgres port, and the name of our database. Enter our credentials. And that's it. We're good to go. Now, in this specific database right now, I've got 0 data loaded. And the first thing I'm presented with is the ability to run Cypher queries directly, but since I've not loaded any data just yet, we're going to start off by just creating our graph, just showcase what it looks like, loading the data, and then we'll start querying the data. So let's just start with that. Now, very easy. Creating a graph in Apache AGE is basically just this. It's like create graph. Name of your graph, so I'm going to call it air routes. Run it. That's our graph created. Now, we've created our graph. The next thing is going to be loading data into the graph. You don't need to specifically declare in your graph what the nodes and the edges are going to be. You can simply just start adding them. In my case, I'm just going to be using a couple of prepared CSV files to load all that data. We're going to run it, get the data in, and then we'll start inspecting it. We'll have a quick look at the CSVs just to explain very briefly how it works, and then we'll go over how you load it, etc. So we've got one here, and we've got one there. There we go. We'll start with this CSV file, which is just our airports. So our airports are going to be modeled as nodes in our graph. Simple structure. Some pre-declared identifier for our nodes, along with a number of properties, name, city, latitude, longitude, time zone, etc., etc. All of that data is basically just going to transcribe one-to-one to a node. So each row in here is going to be a node with 9 properties roughly, which is highlighted there with all these values. Loading nodes in Apache AGE is extremely simple via CSV. Where there's a little bit more subtlety involved is when we want to load edges. So edges are connecting nodes, and so to create an edge you need to know your start node, where you're connecting from, and your end node, which is where you're connecting to. And the Apache AGE CSV loader has a very specific requirement around the format that you not only need the identifier of the start and the end node, but you actually also need to know what the vertex type that you're connecting from, the vertex type you're connecting to is as well. And you can see here in our case, because we only have airports, it's very straightforward. Airport connects to airport via route. But that's something to be mindful of, because that means you have to explicitly know what the label of your from into nodes in your loading workflow is going to be. You also have the ability, of course, to add properties to your edges, since this is a property graph model. And so in our case, seeing as we're just modeling routes between our nodes, we're simply using the distance as a property. So these 2 files, and there's explanations in the loading guide that we've got in the links in the description, are currently copied into my Apache AGE Docker container. So all I have to do now is run a couple commands that are just going to load all that directly into the database. So the first one here, load labels from files, is basically just going to say, I want you to load nodes of type airports into my air routes graph, and I want you to use this CSV file that we've just shown earlier to load the data. We're just going to run that. That literally took half a second, if even that. That's my nodes loaded. We've got about 3,000 or so airports loaded in there. Same idea for the edges, slightly different function. So this is where you can see how Apache AGE works. It exposes a number of functions directly within SQL to perform the various tasks of querying and manipulating your graph data with either Cypher or some other custom procedures, like in this case, the ability to load data. Same idea here. Graph name, name of the edge label, and then the actual file that's going to store everything. I believe we've got a few tens of thousands of entries in this one. That loaded extremely quickly. That's us done. Now, I'm going to do a very quick thing here, which is I'm going to switch to my air routes graph right now. There we go. And now that we've switched over, we're going to be able to start querying it. And this is it, right? So in just a few minutes, I've been able to start up Apache, connect gdotv to it, load some data, and now I'm able to actually query and visualize. So right here, for instance, is our graph visualization. We're not going to spend too much time on it. It's full interactive. It allows you to both visualize the data, but also explore it. You can edit the data interactively as well. So if I want to tweak a little record on the fly, you can simply just edit it in the UI and it will update it in the actual databases. We also have a number of other useful features that make the exploration process, as well as just understanding the structure of your data, much, much easier. So for instance, on gdotv, you've got access to the schema of the database, and that's just going to tell you this is what's contained in your database, this is how it's structured. This is particularly useful for less constrained graph databases, such as Apache AGE, but that applies to actually most native graph databases, whereby there's no guarantee necessarily, especially having defined physical constraints, that your data is going to be structured the way you expect. Developer 1 might choose to create an airport this set of properties that we're seeing here, and then developer 2 might then change the code later and suddenly decide that a property is either being renamed or new ones are added. And unless you're looking directly at the code, for instance, that integrates with your graph database, you're not going to know what the exact structure is. And so gdotv just fetches all that for you very efficiently so that you can very, very quickly get a accurate overview of what your data structure is. That then also allows a number of other things. First of all, normally when you write a Cypher query on Apache AGE, it's going to look something like that, because you're not able to actually run Cypher directly against PostgreSQL. What you have to do instead is use a Cypher function that Apache AGE exposes that allows you to then write your actual Cypher queries. And so that adds a little bit of bloat to the querying process. This is our Cypher query, and everything that goes around it in order for it to run on Apache AGE is in fact longer than the query itself. And that's actually one of the main caveats, particularly in terms of user experience with Apache AGE. With gdotv, we just made that process much, much simpler. You can simply just write your query in Cypher, run it, and we'll take care of wrapping in that little SQL kind of statement and run it for you. And then you can access the results. And so the other advantage is that we have access to full autocomplete and syntax validation. So since we know what the structure of your database is, we're also able to inform you, the developer, the data scientist, the person that is going to query the data, of what the structure of the data itself is. And you can see it right here, where as I'm trying to write my path pattern and I'm maybe trying to filter it on the type of node or perhaps a property, I can see my database has airports, and therefore this is what I'm going to be suggesting. Same for relationships and properties, etc., etc. You also have a very handy reminder on the side there of what your schema is, and that just means as you're writing your query, you're not going to be constantly looking for what does it contain instead, and just now, I don't know. So that just gives you all that right there and then, and you are pretty much guaranteed that the query you're going to write here is going to be accurate and it's going to work. And so then other little things, we've got access to a little bit of Cypher doc. It's worth pointing out, especially if you're a first-time graph database user, that it might be difficult to use Cypher at first. Cypher is a very good language and actually matches SQL quite well in terms of structure and format, but it is a very different language. And so trying to get with the general concepts of it and how exactly you use it can be a little bit challenging. And having the documentation just right here on your screen to be able to do that makes life much easier. And then last of all, of course, is you can then just query the data. So if you run a query within gdotv, we're going to detect what sort of results is being returned as part of the query, and depending on what those results might be, we're then going to provide a visualization that's adapted to the structure. So typically that means if you're returning vertices and edges, like this query right here, or paths, we're going to give you a graph visualization. That's not the only that you're being given. You have the opportunity to view a more plain JSON view as well. You might want to just extract your data, pop it somewhere else, or you can view it as a table, which is quite likely, as a PostgreSQL user, the thing that you're used to the most. That works across a wide array of data types, and no matter what you're actually returning, you're going to be able to see it and inspect it directly within gdotv with additional abilities. Like, for instance, if I go on my actual database here, I can load some additional data interactively onto the graph without having to then run a separate query. And this is particularly useful if I want to just explore the graph data interactively. So without going too much in the details of what gdotv does, and I recommend you check it out to find out for yourself, this is broadly what Apache AGE, how it works, not in too much details. There's a lot more that you can read on their official documentation, how and where you can deploy it, and some hints as to how you can load data, and more importantly, actually get up to speed in using. So if you like this video, I recommend that you go ahead and check gdotv out. It's super easy to install, it takes a couple minutes. You can then connect to your graph database within seconds, and you get this exact same experience. It's compatible with Apache AGE, of course, but then also every leading provider of graph databases, from Neo4j and Amazon Neptune all the way to Janus Graph or Google Cloud, SpannerGraph, and BigQuery Graph, as well as RDF providers such as GraphDB, Apache Jena, or Allegro Graph. With all that said and done, I hope you enjoyed the video, and I hope that you learned a little bit more about Apache AGE. We're going to be keeping an eye on what's going on within that project. There's a lot of active development right now, and that makes it super exciting. And we're going to really keep an eye on SQL PGQ as well for Postgres. And in the future, if there's further features that are introduced in SQL PGQ, we'll make sure to cover those as well. In the meantime, enjoy your day, and hope we'll catch you on the next one. Take care, everyone.